So today we're talking about special triangles. Our first one is a 45-45-90 triangle. So we have a theorem. Theorem 7.6 tells us that in a 45-45-90 triangle, the length of the hypotenuse is the square root of 2 times the leg. So we have a 45-45-90 triangle here. So whatever the leg length is, so for this example I have n. For the hypotenuse you're going to take the leg length, n, times your square root of 2. So how do we know this? So we've been dealing with Pythagorean Theorem. So if we go back to our Pythagorean Theorem, we have a square. We can cut it along the diagonal, which would give us a 45-45-90 triangle again. So if we have the two side lengths are x and our diagonal is d, then we can plug it into the Pythagorean Theorem here. So we have d squared equals x squared plus x squared. So we have a and b would have been our original Pythagorean theorem. So then we have 2x squared equals our d squared. So then we keep going to simplify. We take the square root of both the left and the right. We end up with d equals the square root of 2x squared. So then we can split out our 2x squared to the square root of 2 times the square root of x squared. So then when we simplify that, this square root of x squared becomes just x. So we have d equals x times the square root of 2, which is the same thing we had up here at the top with n times the square root of 2. So let's try some examples. So here's our first one. So we have a square with side lengths of 4 inches, and we're trying to find the diagonal. So what is the length of that diagonal? We can use Pythagorean Theorem, so that would be 4 squared plus 4 squared equals d squared. So then we get 16 plus 16 equals d squared. 16 plus 16 is 32 equals our d squared. And then we would take the square root of both sides. So we end up with d equals the square root of 32. Okay, and we could actually, for the square root of 32, that's the same thing as 2 times 16, which would be 4 square root of 2. Because the square root of 16 is a perfect square, which is 4, so we're left with the 2 inside of our radical. Okay, so you can leave it either way, but we will be practicing simplifying those radicals. Okay? The other way that we can do it is using our Theorem 7.6. So if you remember from over here, we have our Theorem 7.6, which tells us that whatever the side length is, it's times the square root of 2. So if I look over here, whatever my side length is, I'm taking it times the square root of 2, so my side equals 4, so the diagonal equals 4 square root of 2, which is what we found up here. So two different ways of doing the exact same thing. Okay, side was 4, so the diagonal is 4 square root of 2. We have them in both places. Okay, let's try another one. So for this one we're finding x. So again we have our theorem and we have Pythagorean Theorem, which we can be using. So we're finding x, which is the side length here. So I'm going to start with Pythagorean. So we have x squared plus x squared equals 6 squared, which is our hypotenuse. So we have 2x squared equals 36. 6 squared is 36. So then we're going to divide by 2. So we end up with x squared equals 18. So then I want the square root of both sides. So x equals the square root of 18. Sorry, I'll move that down a little bit there for you. So x is the square root of 18. We could also say that square root of 18 if we want to simplify that. We could say that that is 2 times 9. So it would be 3 square root of 2. Alright? So either of those answers would work. Using our theorem over here, it tells us that 6 equals x times the square root of 2. Okay, if you remember back here on the first page, we said that the length of one of our sides times the square root of 2 gives us our hypotenuse, and our hypotenuse is 6. So these would be equivalent. So then we're just solving, so we're going to divide by square root of 2. In order to divide by square root of 2 here, we're actually going to move that to the top. So 6 square root of 2 times, we're going to take it times 1, because we don't like this down here in the bottom, so 1 would be square root of 2 over square root of 2. And that leaves us with x. So square root of 2 times square root of 2 would give us just 2. So we have 6 square root of 2 over 2 equals x. And what is 6 divided by 2? Gives us 3 square root of 2 equals x, which is what we got on this side. So it's the same thing, just two different ways of doing it. More examples. For this one we have a picture. So the figure to the right is divided into 4 equal square quadrants, so that each square contains 8 triangles. So if you notice, there are 8 triangles in each one of those colored blocks. What is the area of one of those squares if the hypotenuse of each triangle is 7 square root of 2? Well, let's think about what we know. With our theorem, we know that if we have a side as x and our hypotenuse is 7 square root of 2, then what does our side have to be? Because we said our side over here times the square root of 2 gives me my hypotenuse, so that means 7 has to be my side length. So each one of my sides are 7 millimeters. Okay? It asks for the area of one of the squares. So if one of these little sides down here is 7, then what would be my area? So that means this one is also 7, and this side over here, these would be 7 and 7, so that's 14. So to find the area of that square, I'm going to take 14 times 14. And what do we get when we multiply those out? You get 196, and then our label is millimeters. You could have also used Pythagorean Theorem there, but it's definitely quicker with the Theorem 7.2. Alright, so the last one here, we're going to be finding A. So we have one of our legs is A, the other leg is A, and we have a hypotenuse of 8. So very similar to one that we did before, we know that the hypotenuse is going to be A square root of 2, and that equals 8 centimeters. So then we're just solving for A. So again, we want to divide by square root of 2. We don't want to leave that square root as a denominator. So in order to move that to the top, we're going to take it times 1, and that would be square root of 2 over square root of 2. When we multiply square root times a square root, they go away. So we end up with 8 times square root of 2 over just 2. And what is 8 divided by 2? We're left with 4, so A equals 4 square root of 2. Okay, that's the last example I have for today. So we'll be dealing with these special 45, 45, 90 triangles tomorrow in class. Have a great evening.